All right, welcome back, students. In this video, I want to go ahead and show you or explain to you how to determine the molecular formula. We're going to use a similar problem that we used in the previous video, and the one that we did before was when we were trying to find out barium fluoride. And so the problem there, I'm just going to go ahead and type it up for you, and then you'll be able to see what the problem was, and then I'll go ahead and proceed to solve it for you so that you can determine the molecular formula. Okay, so here we go. Let me pause this real quick. Okay, so here's the problem that we have. We have a compound X. It's composed of 78.3% barium, 21.7% fluorine, and we're asked to determine both the empirical formula and the molecular formula. And they also provide this important piece of information here at the very end. They're telling us that the molecular mass is equal to 350.648 grams per mole. So that's important. Now, in order for us to go through all this process, we need to actually do the entire problem here. And the previous problem showed you how to do this, so I'm not going to spend too much time on showing you how to do it, except to go ahead and give you the overall formula from this previous problem. And I think if you look at the previous video, you'll get that. And so the formula here for the empirical formula, what we find out from that video was that the formula wound up being BaF2. Now, in order for us to figure this problem out, particularly the section for the molecular formula, what we need to know is what is the formula, the empirical mass. That, in other words, the mass of the empirical formula. This here is the empirical formula. Okay? And so what we need to do is we need to go in here and find the mass of each of these things. So if we go ahead and do this, we know that the mass of barium is going to wind up being 137.328 grams, and fluorine here, there's going to be two of them, and the mass for fluorine is going to be 18.998. And let's go ahead and rewrite that just a little bit cleaner here. All right, so going through and following up here and actually making sure we've got all the math done appropriately, we wind up with a total mass of 175.324 grams for the compound. And so what we need to know or realize is that this is going to be the mass of the empirical formula. So we need to now take advantage of this information that was given to us at the very end, which was the molecular mass has a mass of 350.648. So here's the distinction. If we have an empirical formula, that means that this mass right here is actually the empirical mass, right? And that kind of goes hand in hand with the empirical formula. What we want is the molecular formula. So in order for us to figure this out, we need to make sure we compare. We're going to be doing a comparison between the empirical formula. So we're going to compare here the empirical versus the molecular. And we're going to do this in comparison with respect to the masses. Since we already know what the empirical mass is going to be, that's going to be 175.324 versus the 350.648. Now, what's the difference between these two? What's the ratio? Well, the easiest way to figure this out is ask ourselves, how many times can the empirical formula go inside the molecular? And so, essentially what you're doing here is you're going to be taking 350.648 and you're going to divide it by 175.324. And so let me show you that. And so in order for me to do that, let me go ahead and take some stuff out of the way here. And so I'll do that, and I'm also going to go ahead and remove this out of the way and to clear up some room. So what we're going to do here is we're going to take the the empirical, and we're going to compare it versus the molecular. And what that means is that we're going to take this number here for the empirical, which is 175.324, and we're going to compare this towards the 350.648. And what we said we're going to do is we're going to divide this. We're going to take 350.648, this is grams, and we're going to divide this by 175.324 grams. Grams cancel, And if you do this math here, what you wind up getting is actually a number of 2. In other words, 175.324 goes into 350.648 2 times. All right? Because this is the case, we now need to go back to that original empirical formula, and that empirical formula was BAF2. What this number here, this here is your multiplication factor, which means we got to take this 2 and we're going to multiply it by each of the subscripts in this empirical formula. And so just to make sure that we understand, remember there is an understood 1 here, so we're going to take this 2 and we're going to multiply it both here and we're going to multiply it there. And when we do that, our molecular formula actually becomes something quite different. And so what we're going to wind up getting here is the following. This is going to cause the 1 to become a 2, and the 2, because you multiply it times 2, will become a 4. So here, this here is the molecular formula. All right? So again, in short, what we did here is we took the molecular mass, we divided that by the empirical mass, and we got that from the empirical formula, and the ratio that we got there, or the multiplication factor, we use that to multiply times the subscripts in each of the empirical formula, giving us the molecular formula, which we've got here at the bottom.